Hello again. We are going to do a problem here from 1D Motion. Speed skater moving across frictionless ice at 8 meters per second. It hits a rough patch. It's 5 meters wide. And then after she exits the rough patch, her speed's 6 meters per second. So what's her acceleration on the rough patch? So the initial is 8 meters per second. The width of the patch is 5 meters. And the final velocity after crossing the patch is 6 meters per second. So we'll switch here. Okay, so this is what we are given. And we want to find acceleration. And our picture, this is our ice. Right? So we got a skater moving along. There's a little bit of a rough patch here. So we have the skater here. We have the initial. And then we have some acceleration during crossing the ice. That's going to slow the skater down. And then at this point, we have V final. Oops, so I should make this a little bit bigger, right? Get my vectors right. Okay. So we want to find the acceleration. So the formula that comes to mind for me, and whenever you see these kind of like acceleration over a certain distance and a change in velocity, I always think of the same relationship. They're kind of called stopping distance problems. So V final squared is V initial squared plus 2a delta x. So we have everything we need for that, right? We have delta x, we have initial and final velocities, and so we can just solve for acceleration. So let's do our algebra first. So we have V final squared minus V initial squared on the left side is 2a delta x, and I'm going to divide by 2 delta x. So I get my acceleration is V final squared minus V initial squared over 2 delta x. And now I can plug in my numbers. So I have V final is 6 meters per second squared. My initial velocity is 8 meters per second squared. Oops, I forgot to define my coordinate axis. So I'm saying this is my plus x, and that's my plus y. Okay, you guys should have told me about that. All right, so then I'm going to divide by 2 delta x, so 2 times 5 meters. Okay, so we'll break out our Python calculator. Just have IPython window running, so I have 6 squared minus 8 squared, and I'm dividing by 2 and then divided by 5 again. If I get an acceleration, it's negative 2.8 meters per second squared. And I can check my units here. So on the top, from squaring the velocity, I get meters squared over second squared, and then I'm dividing by meters on the bottom. So one of those meters goes away. And that's it. And so the negative, right, tells me that it's just like I drew in my picture, that the acceleration is in the opposite direction of velocity. And that's why it's causing it to slow down. So again, if I say my plus x is there, my velocities were both positive, I end up with an acceleration that's negative, and that makes sense.